This is Ben Stenson. This is my final project for Engineering 204, Programming for Engineers at UW Green Bay. So for the final project, I decided to do a tire pressure versus temperature calculator. What this does is it shows you how tire pressures will change along a 0 to 100 degree temperature difference. So what I have here is I have a picture of how you would read your tire. Hello, I am Ben Stenson. This is my final project for Engineering 204, Programming for Engineers at UW Green Bay. So the project, we were supposed to do a GUI calculator. Mine is tire pressure versus temperature. The reason I did this was because I find it interesting to see how tire pressures change at a given temperature and across a range of temperatures. This relates to me because in racing, we see quite a bit of tire pressure changes due to temperature. For example, we would set tire pressures in the pits. By the time we'd get up to the staging lanes, the tire pressures might have dropped. They might have raised all because of a 1 or 2 degree temperature difference. So it's pretty interesting to visualize here with the graph. So to use the application here, first we will look at this right here, this picture. It will show you how to read the side of your tire to get all 3 of these dimensions. So the first one is your tread width or tire width, and this is measured in millimeters. So 185 millimeters is the width of this tire. So in this case, you would type in 185 millimeters. This right here is your aspect ratio. So this is basically saying 75% of this number, of this width, is the sidewall. That's the size of the sidewall, is 75% of 185. So we'd write 75 here, no units there. And then you'd put the diameter of your wheel in inches. So in this case, it's 14 inches. And you would measure your ambient air temperature. So we'll say it's 50 degrees. And the pressure in the tires right now is 35. So if we calculate that, we get a beautiful chart here. It's nice and linear for us, so we can read all values anywhere we want. Could read here, here, or here. So this is just showing the relationship of pressure and temperature. But if we look down here, we have 2 outputs. We have our max pressure and our minimum pressure, our max being 38.4 psi and our minimum being 31.57. So what this is basically saying is at 0 degrees Fahrenheit, it is going to sit at 31 psi, and at 100 degrees it's going to sit at 38 psi. And over here we see 2 lights. We have a high psi risk and a low psi risk. Both of them are green, meaning we are all safe to go. We have not surpassed 50 psi and we have not dropped below 20. The reason we put those in there is because above 50 you could risk a tire blowout, and below 20 you could risk a debead or a sidewall puncture. Now let's do a couple of examples to try and trigger these lights right here. So we'll do a 205 tread width tire with a 55 millimeter or 55 aspect ratio and on a 17-inch wheel. And we'll say we're at 50 degrees Fahrenheit again, and we will say we're at 48 psi. Now if you calculate this, you can see our light has changed. We are above that 50 psi. We're at 52, so we have triggered the light. We are not below, so we don't got to worry about it. And the reason there's not a ton of change here is because we are on an all-season tire, and these tires are engineered to reduce the amount of pressure difference between temperatures, because most people are running an all-season tire, and they don't want to be checking tire pressures every week or every day. Next, I'm going to show you a low tire pressure scenario here, so we'll use the same dimensions. We'll do, why don't we do 30 degrees, and we'll do 20.5 psi, just to be a little dramatic. So you can see our peak is 23.4 psi and our low is 19, so we are below that 20 psi threshold, so we do have the little red light on telling us we could have a potential issue. So that's that. So as you can see, I've got 5 inputs here, I've got 2 outputs, and I do have all of my lines of code. This is the tire pressure versus temperature calculator, and that is my final.